session number 3. So we had a little bit of break from last week because we didn't have any session. So let's see. I was gonna share. Take a look at the current progress of everybody. So let me see and get to that screen.
Yeah, we can see your screen.
Yeah, I want to go to my browser to show the road to certification. Where does that go? I think I have to stop doing the slide first. He said cancel out. Okay, so let's see my screen. So this is the batch tracker. So we're in session number 3. So I'm pointing at session number 3. We are supposed to doing service-oriented and cloud run applications. And here the folks is completing the top 3, or actually top 3 completed everything. And then number 4 almost complete. Let's get one more, I think 1 more week to complete. And I believe Roman also got 1 more week to complete. And I have 2 more weeks, actually 3 more sessions to complete. Actually 2 more. So if you go to session number 4, you can see the other check marks. So session number 4 had 3 courses in it. Session number 5, 2 courses, and session number 6, 3 courses. And I think there's still a lot of we're halfway through the session, through the course. So I think you still have a lot of time to catch up. If you haven't catch up yet, I believe you can spend some time and do some of your coursework, and you'll get there. So let me see. I have to reshare my screen, so I'm going to just see. I can try to share the window and entire screen one, share. Okay, and I'm going to start the slide. Okay, so as I said, we're at session number 3, and I want to thank you for those GDG community who's co-hosting with us, and there are many of them. I don't want to go to announcing the names of all the GG community right here. So I just want to thank you, all of you, helping us and then helping us getting audience into our community. So next. So tonight we also have a raffle. We're going to be running a raffle tonight. So there's going to be also 2 winners. I believe you can select any item on this slide. I believe Roman had posted the URL. Roman, is this? I'm not sure this is the right URL. Is this the same correct URL? Oh, he can't hear me. I think that's correct. Okay. I have my tab somewhere else, so I cannot see it. Okay, so just recap of so looking to where we are tonight. So we're going to our journey, and tonight we're going to be introducing microservices and event-driven application and choreography and orchestration. We're going to talk about what those are and developing cloud run a function and deploy them. And then we're going to look at what's coming the next session. So here we are. So we are in week 3. We finished week 2 last time. So in week 3, we have the service orchestration and choreography on Google Cloud and developing cloud and applications. So I mean, this is the agenda. Well, I already mentioned. So we're going to touch about microservices, and we're going to touch about event-driven applications, and we're going to look at in terms of orchestration and choreography. I'll describe what those are. It's kind of interesting. So we're going to go to cloud and functions. So go back. So introduction to microservices. That we kind of touched on those last sessions a little bit. So we talked about last time. We talked about monolithic applications and microservices, right? Monolithic application, as you know, is a single unit, single executable is run on the targeted platform, and microservices is an individual, independent execution environment that is run its primary purpose. You have the independent goals of doing its work. So in order to decomposing a the monolithic applications into microservices, you have to know a lot about your existing applications. Sometimes existing application does not design. This picture looks simple, right? The design is saying the monolithic application design in the componentized application. You can the UI separate, the order components separately, and the review components separate, and then authentication components separate product. So this is easy to do, but in reality, if you have legacy application, it might not have written that way. So you're going to make it a little bit more difficult to decompose. The idea is that you want to break down all those domains into separate services. In the bottom picture showing that the order service is basically the sole responsibility of order service manages the order. And then the sole responsibility of the product service is managing the product. So listing a product, maybe managing inventory, and then the review service is collecting review from the customer, from the user of the website. And then there's the front end web UI, the mobile UI, and authentication service, which is responsible for letting the user come into the website. So so in this, so when you're designing a microservice application from the start, meaning from clean slate, it's much easier if you know the domain of the applications. So you can decompose your business logic into different microservices. I'm following the same example again. So the order service, is independent from the product service, from the review service. So it probably makes sense, when you're considering building this type of application on Google Cloud, it probably makes sense to consider microservice architecture due to some of the benefit the microservices actually architecture offer. You can also start building your application using monolithic approach with module design in mind, but it's not, that doesn't quite fit well into the cloud environment. Personally, I mean, I would start using microservices architecture from the beginning to avoid that to avoid the factoring from the monolithic application into microservices. And microservice architecture is suitable for growing in agile team as well in an organization, so each separate team can independently working on, for example, in this case, they can independently work on order services, and other team can work on the product services, and one other team can work on review services. So they independently work on from each other. So they can integrate at and some integration time defined by the organization. So microservices is small code base, is independent. Like I said, it's a little bit simpler to implement, and then simple to do unit tests because you're so small individual applications, and they can deploy separately. You can actually working on one microservices you want to deploy to the cloud by itself. So it doesn't affecting the overall applications. I also mentioned that become more agile, right? You can actually planning for agile sprint much more easily. So microservices provide a lot of, you can use a lot of different programming language in the microservices. They offer Java, Python, Node.js, Java, TypeScript, and even Golang. I don't know anybody know how to program in Golang. So in this diagram, it's showing that all the servers using Java, the product servers using Python, and Node.js using MySQL. I mean Node.js connect to MySQL. From an architectural perspective, I mean, I tend to want to have also sometimes organization perspective and cultural perspective. We may want to have, depending on the team side and the team knowledge, we may want to just choose one programming language for everything. My last project, I decided that it makes sense for us to go with the Go programming language because it's flexible. It's actually much faster than Python because we were considering Python versus Golang, and it turns out Golang is compiled into a native executable, so it's not interpretive. They're a little bit faster than Python, but there's a learning curve there too. So each microservice that we will touch base on each microservices that its one-time environment and how they run deploy to the cloud. So in Google Cloud, depends on what managed platform that you want to deploy to, like Cloud Run, Google GKE, Google Kubernetes. In Cloud Run and Kubernetes, that you can scale each microservices based on its demand. You can scale up based on the traffic coming in. And Cloud Run also, you can set up auto scaling as well. So you can actually auto scale, have a Cloud Run auto scale based on this traffic pattern. So when you have a microservice application that contain a number of different services, that it's going to require you to deploy each of them separately, right? Does that mean that more work for us to do in terms of deployment? Yes, of course, but the deployment scenario, what I want to say is that most of the time, in the organization, we set up some kind of CI/CD, which is continuous integration, continuous deployment scenario where automation is used. So you don't have to worry about how to deploy the applications. So once you trigger the deployment, it's automatically deployed, and based on the CI/CD script that you've written for your applications. So it's actually quite straightforward. So I have done personally in that environment in Google Cloud. Basically, we were using the automation using YAML to build up automation that to automatically push deploy to the cloud. Okay, checking. I mentioned earlier, each microservice is simpler, but because you separate the different domain into microservices, right? Microservices need to communicate to get signal to do what work need to be done. So there are ways that you can use a point-to-point communications, and it's kind of point-to-point communication is sometimes expecting a response. It may not work well in this in the microservice environment, but this is one of the way that you can use to have service communicate to each other. If you implement each service with a REST API, a RESTful API, then you can have one service call the other, but the service need to know who to call. So this is a point-to-point, meaning that, you have to know which service to call. So the complexity is actually increased in this case. So Google Cloud offer several managed services that we can use to address the intercommunication between services. So here's the list of managed services on this slide. I'm going to just list them here. So the workflow, Google has a workflow engine that you can use. So Event Arc is very similar to PubSub, but it's an event-driven managed service. And then there's a Cloud Task. Cloud Task is a service that you can actually trigger something to work on specific task, and then when it complete it, it notify you the response back. And then you can use the Cloud Scheduler. So Cloud Scheduler allow you to schedule tasks that you want to do on a task basis or interval basis. So let's take a look at the event-driven application, what it is. Okay, so what is an event? So an event is a record of something that has happened. For example, an employee logging into the portal or applications, right? There may be a log of the employee logged on at, it recorded the timestamp, and it recorded, he logged in at a particular time, or a product is being added to the shopping cart, for example. So an event is immutable because it's a historical record of an occurrence. This should not be modified or delete. An event can be generated even though that there's no consumer, right? So event generated, there's no consumer. It's happened. Nobody responds to it. That's okay. The producer that's not aware of the event being consumed, so the event can be persist indefinitely and can be consumed as many times as necessary. So I think I've touched on, based on, look at the diagram on the left, this is point-to-point communications. The diagram on the right is a intermediary communication. So you have a central sort of like an agent or service. In this case, I would say we're going to use PubSub for this, for example, so that everybody on the outside of the intermediary, they can publish something to the PubSub, and then PubSub basically forward that to anybody who has subscribed to the event, and then the consumer can consume that event and they know what to do with that event. Um, so let's see, go to the next. So a centralized event service simplified auditing and control because we we kind of log and what happened. So we have we can do using auto logging what happened to the event, um, uh, and then it can the logging of the immutable event can be used for auditing purpose, and then the logging contain the event occurs and record every change to the state of the application. You can control access to the service and data by requiring authentication authorization at the event service. You can also limit access to each of the event-based services as well. So this is the producer-consumer pattern that I described earlier, right? The producer can also be a consumer, so you can produce the event to other consumer to use, but it can also consume event from other producer. And then producer to create event here, consumer handle event. So there's no point-to-point like a messy web, kind of spider web, kind of like communication is limited. It's very complicated. And then adding a new consumer or publisher as a consumer is pretty straightforward. All you need to do is subscribe to the event that you want to hear. Okay, let's see. So sometimes they talk about the synchronous request and response, which is a point-to-point request. So then if you do a synchronous request, so you post a request to one service and you expect something to come back and you have to wait for it, right? So because in this architecture, the sender need to know where to send, and then the receiver kind of receive the information and need to respond back. And you want to make sure that your communication, doesn't break down. So I'm going to go to the next slide. So if you look at the left side, is the point-to-point communication. If the service break down, then other service would also follows. So that means your application is gonna have trouble. But on the right side, when you have the intermediary communication service, and when one of the service break down, the other still can independently work by itself. It doesn't affect the rest of the other service. So you can restart that single service, and hopefully it'll come back, without any problem. There are two types of messaging. Push-based messaging is more efficient in this case. So that there's on the left side, we're talking about if you have to pull something, the producer need to send the work, put in work queue, and then the consumer have to respond. Basically, do a polling. Polling is sometimes slow, and you have to wait for it. But pushing the events, the producer basically publish it. It doesn't have to worry about once it's published, and then the consumer will get the event, and then it will process it. So yeah, okay, let me see. So next we're gonna touch on choreography and orchestration. So what those mean? So as you know, we have to design our application to handle inter microservice communications, right? And we mentioned earlier. and then there's a business process also involved in coordinating the multiple microservices. There's two useful coordination approaches. There is the choreography and service orchestrations. So I'm going to touch on next. So service choreography is like you look at maybe like a dance performance. So when a dance is choreographed, the dancer is instructed how to perform the dance, right? Each of the dancers know is what they're doing. They're responsible to perform their certain part during the dance performance. It's very similar to service choreography. So each service know exactly what is purpose and what is we're supposed to do for that service. So the order service, they need to focus on processing order services. So each service work independently, and each is responsible for receiving and sending event asynchronously, right? So this is async event happening, and by following a defined set of rules for interactions. So the defined rule is a specification for the messaging that you define in your applications. The challenge is the business logic is distributed, so this business logic become complex. It is sometimes a little bit harder to understand. So you have to look at the overall picture, from a high level application point of view. And service orchestration, and basically uses central orchestrator. This is very similar to orchestra performance. So in the musical band, right? So each musician know how to play their instrument, but there's a conductor and then take an active role during the performance to ensure that musicians are synchronized, right? So you want to make sure the music is all the instruments are synchronized, and producing a very good performance out of it. And the same thing for service orchestrations. So each service performs its task, and then it'll the central orchestrator control all the interaction between the services. So it talked to service A, B, and C, and D. So service orchestration is single point of failure because the orchestrate process are not proceed if it fails, right? If orchestrators fail, that means the whole thing is gonna collapse, right? The application is not gonna work. So we can use Google Cloud, the Google Cloud Managed service called PubSub. Is a fully managed real-time messaging service. We can use this for choreography, and we have to define we have to define a topic. You look at the picture, it says topic. So what's a topic? Basically, is a you can call it thing, right? It's something, maybe an order or something like that. That's a topic. They subscribe to the order, and somebody publishes the order, and then the consumer subscribe to the order. Will get what order need to be processed. I hope you, Roman, if there's any question, help me answering them because I'm not looking at the chat. Okay, thank you, Roman. Okay, so this is an example of a PubSub to the Connect service. This is not microservices architectures, right? Basically, you have a mobile application. This is a little cell phone on the left, and it talk to Firestore, it talk to Firebase, and if it upload an image to the cloud storage, you can set up cloud storage to trigger a pops up message to be triggered to send. So when you publish the something happened to image, let's say we call the topic called image upload. Then you subscribe to image upload. So this upload confirm app basically receive the 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 the, the published message, and it processes, and it's an upload confirm app basically process the image. And so also the resizing service also subscribe to the same image upload topic, and you'll know that the image comes in, you do the resize, and then it put it back in cloud storage. This is how you would use the pops up for this use case. So I mentioned earlier, so I'm going to describe a little bit about the event arc managed service offered by Google Cloud. So it is a Google managed service, and it provides eventing features, and you can accept any Google Cloud sources. So pops up is actually it uses pops up under the hood for its implementation, and also can take third-party providers as well. So the only difference here is that this one can take any Google Cloud services, and then the Google Cloud Service can generate event to this, and any service subscribed to this event arc can receive event from it. It follows the industry standard called something called cloud events format, and the access is controlled by IAM, and the event arc is a regional service, meaning it's only available in the region. There's client library, the JavaScript, Python that you can, or REST API, you can connect it to it. As I mentioned, cloud event is a standardized open standard specification for describing event data in a common format, so that other cloud application maybe can be used to communicate with you. There's an SDK for this as well. If you want to know more about event arc, I would recommend that you go to the documentation, Google documentation, to find more information about this. In the course, they don't touch a lot about this. Just very briefly went to it. So when do you want to use this, right? I mentioned if you want to receive a variety of integrated event source or from Google Cloud, so this will be suitable for you, for your applications. It uses simple rule-based interface to select source, filter and destination, and the consume event using open standard cloud event format. Okay, so Google Workflow is also a fully managed platform, orchestration platform, and you can use it as a central orchestrator for the service orchestration pattern in your applications. So I mean, you can define a business workflow that you want to perform, and you expect some result back. Then a workflow would be applicable to your use case. This also support the API call to stable automation process. Each execution in the workflow is logged and can be also observed in the dashboard. So there's a workflow dashboard. You can see what happened to each service in your applications. And this slide shows an example of a product ordering workflow. So you basically you read and log the inventories. You read the inventory and find out is the item is out of stock. Yet no, it's not out of stock. Then you prepare a confirmation to your customer. If it's yes, you prepare, and if you want to request a backfill from a supplier, and then you prepare a message for your customer and say the product is out of stock. And then you go update the inventory. So this is like a sort of like a workflow sequential, things going through, and then you notify the customer using SendGrid. So SendGrid is an email messaging service that you can use in Google Cloud as well. It's a third-party product. It's not a Google Cloud product. And then you can also notify other communication platforms like Slack. Right? So when do you want to use workflow? And you implement the HTTP service in Google Cloud and want to chain them together, more like a workflow, right? And workflow is the excellent managing service that you can use to create automation to manage your business process in your applications. It's a great choice if you want to perform operation as a set of item or batch data. You can use cloud monitoring to observe the state of the running process, right? You can use logging and cloud monitoring to provide logging information you can look at. I also have the dashboard as well I mentioned earlier. So Cloud Tasks, so this is another one of the services that offered by Google Cloud. So if you have some specific work that can be executed independently, and Cloud Tasks is a good Google managed service that you can use to upload to. Let's say you have a long running calculation or image processing task, you let it go, and then you wait for it when it complete. You can set up your own queue. So this is set up a queue that you automatically process using the queue. And it can return the status indicating whether the task completed successfully or not. And you can set up retry if the task failed. And then you can configure how you want to dispatch your task. So it guarantees at least one delivery and eliminate any duplicate tasks that are created. You can use the token, which is the OAuth token, to authenticate access to the HTTP service. And conceptually, the Cloud Task and PubSub look very similar, but they are designed for different use cases. So Cloud Task use explicit invocation by the creator, and the creator have full control of the task execution. Where PubSub doesn't do it implicit, but PubSub, the publisher just publish the message, and it doesn't know about it. Anybody receiving the response. The publisher basically just push the message, and it had no knowledge of who consumed it, right? In this case, look at the picture on the right. This is up to the consumer to respond to the message. For example, if you have a image processing task that take time to complete, I mentioned earlier that Cloud Task would be better fit in your application because you might want to know the state of the image processing task and when it complete, and you want to control the timing of the execution as well. And this is an example of the asynchronous task Cloud Task use case. And basically, it has the registration level completed in-app purchase and state changes, user state changes. Each of this can be asynchronously uploading the task. It can we can configure the retry policy. And we can configure the rate limiting and then the defer scheduling. It got a flexible routing and for the HTTP target. It's using native GCP authentication using IAM policy. So on the right, these are all the services actually receiving the work from the task queue. So the payment processing service and the game state service. Is run on a different type of cloud service. The runs an App Engine, a Kubernetes, Cloud Run, Function, and Cloud Run. Okay. So cloud scheduler. I don't know. I mean, if you're in a Linux environment, you probably know about the cron drop. So that what it does is it allows you to schedule something to start work, right? It's based on the format, how to configure the schedule is based on the cron format. You can use the pops up to notify something happened, so then other service applications that you can basically have the service to completing a task for you. So you can schedule so have it repeat for a repeat interval. You can repeat it once a day, once a week, once a month. Something like that. I'm thinking you can do a daily. Let's say if you have a data warehouse in your applications that you want to pull the operational database on a nightly basis, you can schedule a cloud scheduler do that task for you. So this is the format that I mentioned using the cron start format. So if you all star every minute, and then you can define the first star you can find a minute, the second and find the hour, and the day of the month, and then the month, and then the day of the week. Here's the schedule use case. So on the right is all the endpoint that is actually processing the task. The sentence app engine is just like the other cloud tasks, except that this can be scheduled and set up a repeated interval. And it could be a batch job is running every night, something like that. Okay. I think I have about maybe 10 minutes. So I'm going to go very quickly, touch on developing Cloud Run function. So we kind of touched on Cloud Run function last time, a little bit in the last session. So it is also a fully managed serverless execution environment. So all you have to worry about is writing a piece of code. You want to have the Cloud Run function to run the code for you. You just have to use CLI or something to submit to deploy your code for you. You don't have to create a virtual machine to run this, right? That's what the service environment is for. It's very small environment. Create a very small environment to just run your function for you. All you have to worry about is write your code, right? You don't have to worry about managing any VM or anything like that. It's also they charge you based on the usage as well. This is called a scalable function as a service. So is that the cloud function? I mentioned this simple piece of code that implements a single purpose functions, right? And it can be invoked from directly from HTTP, right? or you can set up a trigger, the cloud. You can set up a cloud store trigger, just when something happens, something upload to cloud storage, and you can set up a trigger and run a function. You can set up other trigger as well. So you can use different languages, programming language, Node.js, Python, Go, Java, .NET, Ruby, and PHP. I don't know. I mean, I haven't not written a PHP application, but I have worked on one of the legacy PHP application. I'm not sure I like that, but anyway. So let's see, using Cloud Run functions. So it's a convenient layer to connect and extend a cloud service, right? Let's say a cloud server needs something that you want the cloud function run it and then come back, return data to you. And it could be a good example, to use this and easy to write. The code easy to write and it's easy to deploy. You can develop and troubleshoot on your local environment. You can also respond to a pops up message topic, right? So it's very easy to use. So all you have to focus on writing the logic in any programming language that you choose, and then deploy the function and set up a trigger, and then you're done. Very straightforward. There's some features the Cloud function offer. So you can, like I mentioned, you can do a local development and testing. You can set up a local actual Cloud Run function emulators in your local environment. You can develop and test the function in that environment. It seamlessly authenticate your cloud function with other Google Cloud Service using using a service account. So anything you use, let's say any service communicate to any service in Google Cloud, you must set up a service account so that you must provide proper IAM policy to it so that you can access your other service if you want to talk to. So event driven and or HTTP trigger, it can talk to the cloud database, any database, and Cloud SQL, table spanner, and anything like that. Firestore database. It's portable because it's very small, contained function, very focused of responsibility. So that in that function. So the benefits, so it's augmenting the existing service mentioned, right? It's serverless. You don't manage anything, and also auto scale. It can be, you can observe what's happening to the function just to tune the log and monitoring, right? And then it's for pricing is pay as you go. So the cost is based on usage. So there are two types of functions I mentioned: HTTP function and event-driven function. So event-driven function, it can run based on pops up, and HTTP function based on HTTP call into the function. So this is an example of HTTP function. The basically had so there's the URL tied to it. So you can set up so that handle HTTP requests, but you have to provide a URL endpoint, right? Which is the HTTP:// whatever that's pointing to it, and then you use the HTTP trigger. So this is something for ideal for webhook or single-use endpoint. It supports authentication and authenticated requests. So authentication, you can use the token authentication OAuth 2.0 for this. So in the event-driven function, so you can set up. So I mentioned earlier, cloud storage that you can set up cloud storage and trigger the function to run, or pops up can trigger it to run, or something happened in the Firestore and you can trigger something to run, or Firebase trigger something to run. Even if event arc source something happened, you can trigger that function to run. So this, I mentioned all of those. So integrate with other Google Cloud services that support PubSub. So very straightforward. So this is some of the use case here. So this is for data, good for data processing. So like, for example, the example I gave in, the respond to cloud storage event when the files is created, updated, or deleted, right? So you can upload files for image processing. You want to verify process the image, and maybe resize the image, or maybe analyze the image and give some kind of response. You can use for the webhook API, processing webhook and API call from the outside. And they can send HTTP requests, and is good for mobile backend as well. You use for mobile backend, so you can develop mobile device backend responding to event triggered by the Firebase. For IoT is the Internet of Things. It's very popular. You have a lot of Internet of Things, a lot of things publishing data from IoT. You can use it to process data coming into your applications. So this actually go to PubSub. I kind of did something similar to this, but I did not use a cloud function for this purpose. So we have a we have a medical device that we developed that it generates data, and then we send it to Google Cloud, and then it actually consumed in PubSub, and then we get the data in Cloud Run, not Cloud Function. So this is the language that you can use. I mentioned it. So Go, Java, PHP, Ruby, Python, Node.js.NET. And for those people, for those folks who they used to you're used to .NET, you can still use .NET in the cloud environment. Then you can just create a container, have .NET support, and then there you go. It should just work. So this is kind of like a directory that you have to put all your files in. For Node.js, of course, you're going to have a packet.json, and you have the index.js, or maybe the index.ts. Right? In Python, you must have main.py, and then the requirement.text. In Go, you got to have the go.mot, and then the Go function. My function is this is how you write a Go function. That's the root of the source directory. And of course, function, just like in any other program, it must have an entry point, right? So this is the function.http. So that's the entry point right there, my function, and then your code's right here. You have to define in the main files, right? The index.js or index.ts or main.py. So Cloud Function is regional only. You can deploy, I believe you can deploy a different zone within the region. Is managed entirely by Google. You don't have to worry about any infrastructure maintenance. It's also set the redundancy. Oh yes, redundancy across the different zone in the region. it's effective, because depending on the cloud run function and generation, so regional availability affecting the price tier pricing. I'm not exactly what's sure that is. So deployment is simple. Write your code in an IDE that you like, and debug and testing the code. You add the configuration, and then you use you set up the using G Cloud to deploy it, and that's it. Um, yes, don't forget about the IAM policy, because if you need to access any other services within Google Cloud, that you have to do it. I think I need to stop soon. Roman, are you ready to do this? I think this is my last.
Can you hear me?
Yeah.
Yeah, I had to join through the phone because my computer's audio is not working.
Okay.
But yeah, you can wrap up the last one and then we'll do the raffle.
So I'm going to just fly through this, this deploying process, the build process, and that's it. This is the last piece. You can set up a build process, automated build process for this as well. So you can write a YAML script and then straightforward to do it. I think that I'm done.
Awesome, great. Yeah, thank you, Kevin, again for sharing your expertise. Let me actually share my screen that way, because I'm on the phone, but I have to share my screen. So let me know if you guys can see it now. Give me 1 second.
Something happened to your mic or something?
Yeah, something with my computer. Yeah, something weird, and that's why I had to jump on this one. But yeah, Kevin, thank you so much again for again sharing your expertise. Again, everybody, this was session 3. Thank you so much, everybody, for joining. We're gonna stop the recording and then we're gonna do the raffle. But I just wanted to say thank you, Kevin, again. For those of you watching, make sure to stay tuned for all the upcoming videos on every session here on YouTube. So thank you, Kevin, for sharing your expertise. Have a great day.